All right, today we're going to talk about one of the biggest game changers in cloud computing, Terraform. We're going to look at how it lets you take all that messy cloud infrastructure and turn it into clean, simple code that you can build, change, and manage safely. You know the feeling, right? Spending hours just clicking around in a cloud console, trying to set up a server exactly like the last one. You're always worried that you missed a step or that your staging environment is totally different from production. It's slow, it's super easy to mess up, and it just doesn't scale. Well, there's a much better way, and it's called Infrastructure as Code, or IAC for short. The idea here is pretty revolutionary, but simple. You treat your infrastructure, your servers, your databases, your networks, the exact same way you treat your application code. You write it down in files, you check it into Git, and you automate the whole thing. So here's the game plan for this explainer. First, we'll cover what Terraform actually is. Then we'll get into its secret weapon, which is the state file. After that, we'll walk through the commands you'll use every day, look at how to organize a project so it doesn't become a mess, and then we'll wrap it all up with why this is so important for any team working in the cloud today. Okay, first up, what exactly is Terraform? Let's get into the big idea behind it. So, at its core, Terraform is a tool that lets you build and manage all your cloud stuff using these simple, easy-to-read configuration files. It uses a language called HCL, which was made by HashiCorp, and it's designed to be super intuitive for people to write, but also really easy for computers to understand. And this right here is probably the most important concept to grasp. Terraform is declarative. What does that mean? Well, instead of giving it a step-by-step recipe, you just show it a picture of the final pizza you want. You declare the end state, and Terraform figures out all the steps, the recipe, to get you there. This is what makes it so incredibly powerful. But for that to work, for Terraform to figure out the recipe, it needs to know what it's starting with. It needs a memory, kind of like a brain. And that brings us to its single source of truth. This is the one thing that makes the whole system tick. It's what prevents you from making huge mistakes and lets your team work together without stepping on each other's toes. And that secret weapon is the state file. It's a JSON file, usually called terraform.tf state, and it's basically a map that connects the resources you've written in your code to the actual resources running out there in the cloud. Think of it as Terraform's perfect memory of everything it's responsible for. Really, it all boils down to this one comparison. Your code, all those .tf files, that's your desired state. It's what you want the world to look like. The state file, the .tf state file, is the current state. It's what the world actually looks like right now. Terraform's main job is just to figure out the difference between the two and then make a plan to fix it. And this state file is absolutely crucial. It's what lets Terraform plan changes so accurately. It also detects something called configuration drift. That's what happens when someone gets impatient and makes a manual change in the AWS console. Terraform sees that. And here's a big one. For teams, you have to store this file somewhere remote and secure so everybody is working with the same version of reality. Okay, so we get the theory. Now, how do we actually use this thing day to day? Well, it's all built around a very predictable and, more importantly, a very safe workflow. This is the cycle you'll use over and over. First, you run a init to get your project ready. Then comes the most important step, plan. This gives you a preview, like a dry run of exactly what Terraform is about to do, what it's going to add, change, or delete. Nothing happens without your approval. Only when you like the plan do you run apply. And, of course, when you're done with everything, destroy tears it all down. Now, this brings us to a key property with a fancy name, idempotency. It sounds complicated, but the idea is simple. Running Terraform apply with the same code over and over again will have the exact same result as running it just once. After that first run, Terraform just looks and says, hey, everything already matches the plan, and it does nothing. This is huge for preventing duplicate resources and keeping things consistent. All right, we've got the concepts down. Let's get practical. How do you organize a Terraform project so it doesn't turn into a complete disaster? Because, trust me, as your infrastructure gets more complex, just throwing everything into one big file is a recipe for a nightmare. Having a clean, consistent project structure is absolutely essential, especially if you're on a team. So here's the standard way to do it. Your main resources, like your servers and databases, they go in main.tf. Any inputs you need, like usernames or region names, go in variables.tf. Anything you want to export, like an IP address, goes in outputs.tf. And finally, providers.tf and versions.tf handle all your cloud provider configurations and lock down the versions you're using. And speaking of versions, once you run Terraform init, you'll see this .terraform.lock.hcl file pop up. This thing is a lifesaver. Its only job is to lock in the exact versions of the cloud providers you're using. You should always commit this file to Git. It guarantees that what works on your machine will work on your teammate's machine and in your deployment pipeline. So we've walked through how you go from just code to actual cloud infrastructure. But what's the big payoff here? Why does any of this really matter? It really comes down to 3 huge benefits. First is reproducibility. Your Git history now becomes a perfect audit trail of every single change ever made to your infrastructure. Second is collaboration. With things like remote state, different developers can work on the same environment safely. And finally, you get multi-cloud consistency. The same commands, the same workflow, it works for AWS, Azure, Google Cloud, you name it. Now, to give you some context, let's see where Terraform fits in. You've got CloudFormation, which is pretty similar, but it only works with AWS. Then you have tools like Ansible, which are more for configuration management. That means installing software on a server, not creating the server itself. A good way to think about it is Terraform builds the house, and a tool like Ansible furnishes the rooms. So I'll just leave you with this final thought to chew on. Once your entire cloud environment is no longer this fragile thing that only one person understands, but instead it's just clear, version-controlled, automated code, what does that unlock for your team? How much faster could you move? How much safer would you be? That right there, that's the real power of Terraform.